All right, hello everyone. This is Jun-chan, and we are back on stream. And yeah, let's do some housekeeping there and date the log. And so we are now moving back into doing some streamer tools. So back playing with the GStreamer editing services with Haskell. So let's see how we're gonna do this. 22 to next week, which should be, let's see, yeah, maybe 28, right? And we're doing streaming tools. So that's one thing. So that means we copy this log to find out where we left things. But before I get more into it, I wanted to configure my chatty account. So yeah, let me just connect here and check that I actually have sound and notification for chat. I'm also going to try what I was looking at last time, which is using the apps dashboard. See whether that actually works. I'm going to get my phone charging and see if I go, yeah, leave this the chat room open here, and then at the same time look at the preferences. And I think I needed a sound file, basically. So not sure where I find the sound file, because I think the basic sounds in notifications. I think there we go. Chat messages here. If I edit this, had things set up, but no sound file, so therefore no test sound. So let's see, how am I going to get sound files? Yeah, that's an interesting question. Integrated into notifications, fine. Sound notification settings. Okay, so looking for sounds, .wave in the download folder. That sounds fine to me. Let's go check out a free wave open source chime. And we have Sound Bible visibly. And let's see, how is this? It's a bit low, right? Magic wand. It's kind of cute. Okay, doorbell. And where is the sound coming off? I'm not hearing it. Oh yeah, I see. It's because of, yeah, it is coming out, but it's this trade-off between monitoring my voice and actually hearing the computer sound. So that's not the best. So I'm never simple sounds. But let's first find the interface. Okay, a bit too big maybe. Church bell, clock chimes. Yeah, those are repeated sounds. So you know what? I think I'll go with the magic wand. Yeah, it's kind of cute. Except they're supposed to be downloadable. That's an ad. And wave. Okay, great. And save file. And rescan folder. One sound file found. And now we go into events, edit this, and sound. That's a magic wand. And we can hear it. Except that now, ideally, I'd want this to output to a different soundboard, but is that doable here? Ah, yes, output device. Yeah, so, okay, hold on. This is HDMI 411. Maybe it's coming out actually through my screen. Let me just check. Without my headphones. No, it's not. So let's try with. So if it's not HDMI, NVIDIA, HDMI 3, I'm HDMI 411. Okay, so maybe HDMI 311. Let's try. Colors. Colors is fine. That's not what I want to test. I suppose I could just leave them where they are. Okay, apparently can't. So let's move back to 411 and test again. Yeah, I think I will hear it. Yeah, well, should have picked something. I think a little bit more, a little bit louder actually. Check one, check. Okay, let's pick something a little bit more. What's this computer magic? Okay, maybe I need a beep. Not very pretty. Okay. Yeah, I think I can live with that, actually. That's kind of nice. So let's save it. And we're going to need to rescan the sounds. Got two things now. I could also try another audio device, right? So let's try that as well. I see. And events and change the sound to beep. Okay, so that's coming out of the desktop computer itself. So let's go for another one. What's default? Did it again. Okay. Okay, so that's definitely my the sound card in the microphone. So I don't want that. Try PCH. Let's not make the same mistake. Hopefully, can't hear anything. NVIDIA doesn't seem like a candidate. So I think we're back to, well, let's try a few more. Like, how about this audio thing? What's that? Seems to be my VR headset. So same thing. So maybe NVIDIA. Well, let's try NVIDIA, I suppose. NVIDIA. Would that be? Yeah, it could be that that's actually right. Oh, I did it again. Let's try. Boom, bum, and can't hear anything. So not that then. But let's be optimistic and try another NVIDIA just to see. No. Okay, fine. Let's revert back to I've tried one of those. I think I've tried 311. Okay, I'll try 3.3 just because, you know, who knows, sometimes. Yeah, sometimes things work, but they don't now. So I think we want to be with default and just yeah, and I think I will hear it basically. Check, 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 check. Yeah, I think that's a reasonable compromise. So then let's put the chat on the side. And where are we now? Well, I suppose I could put a little bit of music on, right? Because that's how things were when I was a little bit more organized, and I will need to solve this sound card thing a little bit more durably. I don't know how to do that. Okay, let me check whether actually it's supposed to play, but yeah, I think it is playing. It's just very low level, very low volume, I think. I'm gonna try and listen to it live on the chat. Can I do this? Okay. So still not the best, but hopefully better. And let's. Ah. Okay, so I'll talk a bit so that I can actually then monitor things properly without the sound here. Yeah, so it's actually very faint, and I'm still testing here. 1, 2. I would actually need to have a longer delay in order to be able to hear the difference. Sound is not ideal. Is my... Yeah, I think it's very faint. So let me mute this. But yeah, I'm eager to do some Haskell. So let's get to it. Oh yeah, I did want to test whether actually I can hear the chat notification with this setting. And so let's do so. And it's not very easy to hear. Okay, well, I'm going to change slightly my monitoring. Check, check. Okay, yeah, I suppose I have to do it that way. Ah, this microphone is so good, but This is really a design mistake on their part. Can't believe they did that. And how is my... Yeah, no, that's full. Yeah, okay. That's not too bad. And yeah, so let's look at our log. So the broader context here is trying to explore like this design space of tools between a video nonlinear editor and a music digital audio workstation and something like OBS for streaming. So with some ulterior ideas on how then that could be used maybe for, you know, kind of open work process where we try to both do what I'm doing by just working and learning in the open, but also somehow be able to accumulate the results of what's being done in a way that can then be very easily, or as easily as possible, be translated into a shorter, more to the point suite of content chunks that can be published to YouTube and that are sort of self-contained and hopefully well produced. So the building blocks for that, apart from some kind of more experimental and speculative thoughts on user experience, is to use basically GStreamer as a media engine, and more specifically GStreamer editing services, or GES, in combination with plain GStreamer, to achieve sort of this hybrid non-linear editing and streaming pattern first, and then apply maybe some digital audio workstation sort of UX pattern to it. So what were we doing? We succeeded in launching a simple GST pipeline from Haskell. So let's see whether we can actually reproduce that. How about that? That would be a nice start. And where is it? It would be this, I suppose. Streamline, yes, it would. And so let's see where we are here, and we have Streamline. And then what we would next develop, I suppose. And then we, oh, well, actually, I need to exit next develop and go into Streamline, and then go back into next develop. That'd be the better way. And then I would I could kebab run. Is that how we were running things? Oh well, that's not going to help. I haven't started a README here, so let's start this. Experiments on streaming tools with Haskell. And so for now, I think starting it is what? Cabal build, Cabal run, Streamline, dash, and some video, I think. Right? Do I have Streamline here? No, it's not in the cache anymore. Let's see, the shell, yeah, that's just a wrapper, and here we have whatever we want. And so I think that would be Cabal run, Streamline, and then name of the file. So I think, and I think we have stuff in videos and whatever, right? Let's try that. Cabal run, Streamline, and in fact, I think we can maybe even not have the dash, and then try, well, yeah, try the MKV. How about that? Does this work? Oh, what? That is quite strange, but apparently just a temporary thing. Seems to be recompiling, but successfully, and linking. That's a strange, oh yes, and it works. Amazing. So sample.mkv will be our current test. Actually, really needs develop, right? And then from the next develop prompt, which for us is next develop, would be doing this. Very good. So I like this. Our tooling is working in our favor. Okay, walk through the documentation. We did that. Look at tracing. We did that, and it was mostly basically piggybacking on the whole GST tracing infrastructure, like creating a tracing module seemed like possible, but way out of scope for this. There's a number of toolings to analyze traces for different parts of the tracing subsystem, and they're mostly activated with like a GST debug or GST trace environment variables. So not the most interesting, but we looked at it. And then the GIGST library itself, understanding why the sample pipeline send an EOS. Right, so that's just, we found out that there was a particular GST element that did send an EOS, but others didn't. So that was causing issues with the basic pipeline code, which we can refresh our memory with. I think I've moved this into engine. And yeah, we used decode bin 3 here. And because we had an event-based, like a bus, like event dispatcher of sorts that looked at all the messages sent by the pipeline, we were pattern matching on EOS and here message type EOS, and that was exiting the pipeline prematurely. And it seemed like EOS was actually sent because this decode pipeline, this decode bin 3 GST element is using is a dynamic element, and I think that the moment where it's actually doing the sort of the reading the file and then dynamically creating the actual elements that are going to be part of the decode sub pipeline, it sends an EOS in the meantime. So yeah, just a bit of probably a kind of bug, really. Dynamically change an element property like file source location with the imperative API. So I believe we did that. Let's see how we did that. I think I set up a timer. Oh, sorry about that. Yeah, I set up a periodic clock such that after some number of nanoseconds, I believe, it would switch to a different location. So in fact, this should just be working. So if we're patient, then this should then, after I think 10 seconds, this should then swap to my starting screen. There we go. It just started to like so switch, and then it displays switch on the command line. Wonderful. So all of this works, and then what? Then there was this idea of trying to see how we could convert the existing imperative API using the same approach that Oskar Wickstrom used to convert the GTK part of the library into something that's more declarative. So that's actually pretty hard because that led us to a bit of a kind of a big tangent, because one of the difficulties of this is that we're going to need a good underlying data structure that will represent the state, and that such that basically the parallel will be, and so let me maybe write this somewhere, like in terms of like declarative GST. So in the way that GTK GST declarative maps imperative calls such as like create button to an incremental change on the state of components, adding a button, such that then rendering is state to basically an imperative. Well, it's really state change to an imperative call. So that's an interesting difference in the API actually, because rendering we could see as state to UI, say, but here I think everything is based on deltas. So let's go take a quick look, because I think that's sort of that's not going to make us move forward so much in terms of like UX and playing with GES per se, and so maybe we'll have to make a call at some point. Maybe we do want to play more with GES rather than just plain GStreamer, because that's going to produce its own challenges in terms of whether we're going to need to create some bindings for it, and that's going to be a whole other interesting domain. But one of the more theoretically interesting things is that I've been quite fascinated about is this idea of like sort of incremental UX, and I think there's something maybe if we do like a kind of a delta based system, then maybe that's a little bit like Purview, I think, like the PureScript Purview, whereas this is more like maybe maybe React. It's not really. It is, in fact, but it's just it's the lower level of it's the implementation of React. But no, it is React, except that React basically uses the VDOM as the underlying. React is kind of like it's kind of like state in props to state diff to VDOM diff to kind of VDOM patch, maybe we can even say. That's more like well, actually it's like VDOM diff to DOM patch, I think is the correct way to think of it. So whereas I think Purview is maybe more direct, it's more like state change to DOM patch, I think, something like that. It would be interesting to actually see whether that's the case or not. So let's leave this here in this form and see whether we can fill in the blank for Purview, and see whether we can also fill in the blank for GI/GTK declarative. And we looked at this last time, so it should not be too hard to get back into it. But I suppose I need to find the appropriate window where we played with these things. So let's look back a bit. So probably not this. Actually, I think this can probably just be closed. So let's do so. So maybe here the int graph. Yeah. So that's actually probably part of it, and declarative. Yeah, it is exactly it. Fantastic. So the declarative hello world in this case is so no, that's the imperative style, and declarative style will be we have a view that takes a state to declarative widget, and an update function that based on events transitions to a new state. And this seemed to be quite interesting actually, that this transition can be either a transition or an exit. yeah, I have to look at this. It seems like an interesting approach. And then it just runs by saying this is the view, and right, and then these are the updates, and then basically clicks will trigger the events, which will change the state, and then things are kind of wired in a way that I suppose is sort of abstracting the actual point, like event point, and just sort of a wiring of streams. It's in a kind of an FRP sense. And wiring the event listener to a particular attribute. Well, no, not really. Yeah, wiring the event listener to a particular state change that's defined elsewhere through an update function, and then the state change then is such that the view knows, depending on its states, what to do. So click or not clicked, and then button clicked. So yeah, so it's a particular way to wire things. I do have to ask myself if in fact I really do want, that's really the next logical step for me, or whether in fact I want to start merging with what I've been starting to look at with deny. Because yeah, on the one hand, this seems like maybe for views like things, it might be more easy to understand, but because I think specifically because in a kind of a 2D UI context, we end up having things that look a bit like trees, state trees, and so we can have sort of widget that look also like state, like widget trees or component trees, and that fits this model well. But I think it kind of breaks down in terms of conceptual simplicity when you switch to things that have more temporal component, and then also less kind of encapsulation in a tree. And like, for instance, like more like a network, or like a or a graph. So that comes back down a little bit to the fairly central role of the kind of state carrier, you could call it, right? Because whereas in like in most 2D UX stuff, it's the tree, a tree of component states. Here we're kind of saying maybe for like a pipeline, which is sort of the main thing we're manipulating here, then it seems like the graph might be the better way. Then it could be that a particular component or particular element or node in the graph or vertex, that maybe one of those has a 2D, more traditional 2D UI substate. But so then I suppose we have something that kind of transcends the 2D UI thing, because we could just have like a simple like a simple linear graph with like something that ends up looking a bit like a data source or an event source, a UI vertex, and then an event sink with a kind of a return loop here. Which is basically the driver model that I'm interested in also, aka driver model, or dialogue based IO. Dialogue with streaming based IO. So in that case, there's no real dynamicity to the graph. Graph is static, and then there's just one element that has a 2D substate in there. When we talk about ANLE, OBS, BLOD, DAW, all of the acronym soup that I'm looking at here, then we have a dynamically connected graph, and there might be a projection of the graph onto a UI, but that wouldn't be a substate. That would be some kind of projection. So there's a like the global, or maybe the how would you say the graph UI, I think global graph UI maybe would be a projection of the pipeline. Like, let's call it like it's the multimedia engine graph onto some 2D or maybe 3D UI. That's fine. But then in addition, maybe we'll have, as part of that global graph, we'll have also things like subsets, like little floating windows for element state that are like 2D, 3D UI widgets, right? So very much in the kind of how this called, like that GUI or something. Yeah, exactly in this way. Maybe there's no examples, and there's no API documentation. So okay. Wow, that's sad. That GUI example. Code sandbox. Yeah, that kind of stuff. Yeah, anyway, that is not worth looking into much more than that. Okay, so I think that makes sense to me, and so that's less about the state carrier and more about like UI. So does this mean that possibly we want to, given that we're saying that maybe these graph rewiring primitives, that they manipulate vertices that can encapsulate state that would be tree-like, that then when we zoom in, that we sort of somehow try to compose a declarative approach like this together with something which would contain it, but that is more graph-like. That sounds to make a lot of sense, actually. So let's see what that would look like if we are a little bit speculative in how. Let's kind of design.hs. Yeah, please. That sounds great. And so, yeah, we'd be saying something like, if we have what's an example of something that would have a widget in a multimedia graph? It could be, well, in fact, it could be something as simple as an automatically generated set of drop downs and checkboxes and whatnot based on the GI and the introspection library for GST, for GStreamer. So that's a possibility. And then I suppose if there is such a thing, then, well, then it should be something like, well, I suppose we would call that a widget. And it would take the state, so that's all good. So maybe it would say like state, there would be like so we need to think about how we compose state and substates, which is a pretty frequent question, but I think it's not solved here. Something that leads us to, I suppose, again, like the kind of the grain way of doing things. Pure script grain. I shouldn't distract myself with that too much. So what would be an example? Well, there could be an example where we have sort of a you have a view custom or something. Let's not call it view. Let's call it a view. It would be for, let's pick something concrete here, like so would it be like a microphone input? Like it would be an audio input, for instance, audio input. There would be like an audio input default or something. Well, yeah, but except that this would be the custom one that we would be writing here. And the custom one would so it reacts to state change. So here state is just not click or click. So let's say like data state audio input would be something like, well, it's either let's say muted or active. That's one thing, right? And then if it's active, well, to be honest, we probably need to make a product of this. Yeah, so the kind of isomorphism between the state shape and the widget shape will appear here. So I suppose we could have a kind of a DSL here that we would map onto the GI introspection, but that would be more of our own, or we could reuse elsewhere. That would allow to derive a default custom view. So if that's the case, then I have trouble imagining something that wouldn't be a record here. So it would be a record of like status, and we wouldn't be able to use inline definition of the type, which would be sad. Why wouldn't we be able to do this? Sorry. Yeah, I think this just doesn't work in Haskell, right? We can't do. Let's try. So Haskell AET inline. Maybe we need a sum of product interface kind of thing. not gonna help. Okay, I need to put something on my back. I'm sneezing. I'm sneezing. Okay, I'm back. So let's try with the nested keyword here. Sum and product are true sum of products. Why sometimes matters. So that is a sum of products actually, right? So I'm just trying to do product of sums. This is probably why I'm getting. Whereas I could do state. Or I could do muted or active. With active needing the payload, so that as long as it's muted, then I don't need. So what would it have? It would have like the hardware ID or something, and maybe the sampling frequency and the bit rate. And this could be actually the muted or not, right? So then this would be a sort of a live input, but we could also have sort of a recorded input, and then it would be like a handle, right? Like some maybe URI, and like also sampling frequency and bit rate. But maybe actually this is not where the muting happens. Maybe there's not the right separation of concern. Yeah, so if that's the case, then you'd imagine that would translate into, well, if this is live and you know, blah blah blah, then you display like the widget with, you know, well, let's say this was a hardware ID. Then maybe there'd be like some you know, some label with the, I would say like hardware ID and as the hardware ID or something, probably like that. And such that when on maybe on modify, well, really no, you'd want to encapsulate that into some like a field, some notion of a field, and then I suppose the field will have an ID and like a value or something, right? And then the value will be the HID, and then would we need a kind of a handler, an event handler? So I think we need an event handler only if changing this wasn't encapsulated, that it somehow affected the broader global state, or even the components. The components on state, So that's interesting, because then you think, well, then you want to do like on change, and sort of not button clicked, but what would it be like let's go back to the declarative thingy, not clicked, right? So the event is button clicked, and then the update text button. So yeah, so I don't know if I like this. Update audio input custom would be something from state and event to whatever. Let's say just state. Such that it would take like well, yeah, boilerplate. Take the HID or something like yeah, this has all the same shape here, so I don't know whether we need such, meaning the what I'd like is to derive that's sort of one of the things I've been chasing. I think is like I want to automatically derive an incremental data type for what an increment of that is. It would tell me, well, yeah, for this you can either change the hardware ID, change the sampling frequency, change the bit rate, and such that it would have annotations such that hardware ID, well, it's kind of an arbitrary thing, sampling frequency is actually kind of a drop down, and so then the delta types that would be automatically derived would be using this type level annotation information to both type check a delta, the delta type, but also just be able to actually just enumerate or create delta types, or even like enumerate delta type subspaces. Actually, that would be a way to populate a drop down box. Okay, so I should note all this. So the holy grail here would be to derive a delta type from the state type, then be able to enumerate the delta type space to, for instance, create the options in a drop down, or even derive the drop down from the delta type, meaning, or even the whole component for editing the state from the state type. That's really what I'm after. It's like write this, get the UI, get all the wiring, and then be free to decide what to do with those things. So meaning that sure, we could possibly customize, but not so interested in the customization. It should still be possible, right? But it should really be like kind of like something like take the generic thing and then append it with, or override it with this interface. Okay, so what does that mean? So here we're going back to the problem. Here we are also looking at like something that has like this tree like state, I suppose, but that's not our global state. So like the data state pipeline is kind of a graph, right? And so what did we do with graphs? I think we played in the model thing. Yeah, we were playing with these variants. Nowhere too close to be able to get to actual graph things, right? I think we did play with graph things though. Is that in types? No, that's pure script. I remember playing with Alga. Did I import Alga here? I did import graphs. But did I start playing with it? Doesn't seem like I did. No. Did I take notes from that? I think I did, but let's see where. The bee's knees. Matrix routing, grouping, limited data recording. Okay, I don't know what that means. Sorry. Schema, maybe. Oh. Yeah. I did go down a graph rabbit hole. And graphs were somewhere there, right? So graphs, simple monadic graph library, and that was Ed's. I thought I played with this. I might have done like Cabal REPL kind things, type things with it. Yeah, that's what I did. Oh boy, so wish that we would be in a more modern time where my Cabal REPL things would have been automatically sort of saved as part of my console slash notebook IDE unified thingy. But we don't live in that world. So those experiments sort of disappeared is what is the sad truth. I mean, they are in video on Twitch and whatnot, and our YouTube right now. So let's go take a look, I suppose. Videos. Streaming tools. I think it was one of the streaming tools things. So let's see. Definitely very streamer. Ah, there we go. Oh, so I play with this in the declarative folder. Yay, it didn't disappear. Check it out. Yes. Awesome. Right, so I had written some thoughts there already. So let's see how that reconciles with what we're just talking about. Declarative thing, graph patching. Yeah, so I was trying to find some I was focusing more on like trying to see whether like an adjacency matrix style approach would okay, I'm gonna need to move you over here. If an adjacency matrix style thing actually corresponded correctly to a sort of a visual representation of a patching matrix, and that corresponded to the actual graph. So that is something that I still haven't actually really found out about. So let me write this down as a to-do here. So is an adjacency matrix for a graph the same as the kind of like the matrix routing representation. And I think the answer is mostly not, but I think it would teach me something if I look at this. Then we're kind of like choosing a underlying state data type for pipelines, which by the way is not the same as the underlying state data type for GES components, structures, shapes. That's not going to be the same thing. So possibly if we already had something that's a little bit composite, where we have graphs containing nodes that themselves have kind of tree-like states, then now we're talking about maybe having even a top-level container that is either something that contains the graph, could be seen as something that is in fact sort of the temporal evolution of the graph. Or is it also what? Or is it just a sort of like another facet, like a projection, or a projection, or something larger of which the graph and the GES shape are projections of, like some hypergraph or something. Right, something of like higher dimension, some that can be projected into a graph, which starts sounding like that could be the same thing, because you could define maybe the evolution of a graph in time as a hypergraph. At least a graph. Yeah, you're considering like that maybe a graph homomorphisms are themselves somehow in the category of hypergraphs. I suppose that's probably true. The temporal evolution of the graph. Yeah, so that sort of starts to make me think about, yeah, like Petri nets. And where was it? Like like essence of data flow programming, essence of data flow programming. So yeah, like comonads as the sort of temporal exploration structure, possibly. I don't know if that's the best, or this is becoming super abstract, right? Okay. But then the difficulty is that if I just patch a tree onto a graph and then whatever, like, you know, I suppose like something super simple would be, or super simple wouldn't be super simple, but no, I don't even know what would work there. Well, yeah, we could imagine that it's just kind of like a timeline somehow, a timeline of deltas of both the graph and the graph vertex substate, right? So some like more like a dispatcher of sorts. That's kind of a simple way to think of it, right? It's like, sure, these deltas in fact represent the movement of a graph into this kind of hyperdimensional space, but we don't need to think about it so much because that's equivalent to just having the list of the actual deltas. And I think that corresponds maybe to that. It feels like GSE, you know, like, but from what I remember of it, like that it's, you know, transitions and clips and rewiring of the GST pipeline based on that, and of like which gets output to the, you know, to the sink at any given time, transitions between two active things. Sounds like that could all be described in a language of deltas, plus that thing that I was exploring the other, or at least mentioning. Look at this essence of data flow. Which would be like resolution independent transitions and things like, so like resolution dependent transitions could be part of the language of deltas here at this level. So if we do that, yeah, then we're kind of like moving the problem around a little bit in an interesting way, which is we're almost saying, well, maybe instead of defining the states, we define the deltas, right? The language of deltas. It's kind of the same thing. So what does this mean? It means we say, yeah, the state of the pipeline is, let's say it's just a graph. And yeah, I feel a bit like using the algebraic graph today, just to confuse myself more. And use this edge labeled version. So something like that, right? So it's a graph. Yeah, right. Then we encounter this problem that this is of a single E type and a single A type. So what we want is like to do kind of that is kind of I mean, more possible with this structure, which is inductive, right? So we could have E prime, A prime, so to speak here, meaning we could be linking to a graph. So that's what is it? It's isn't that an indexed? Can we make this an indexed graph? I.e., so like type changing, a type polymorphic. It's not type polymorphic. It's like heterogeneous graph. Okay, we really have to have that actually. If with our model, like we wouldn't be able to do anything if we don't do that. And then we'd have to, so we'd have to be able to dispatch a delta to of a particular type to a particular vertex. And to be honest, a particular edge. There's no reason why we wouldn't be able to do that with edges too. And then obviously we want to think about what edges represent in this pipeline. Compatibility of pipelines, path of objects, elements and arrows, and I also have that guy here. In this representation, index path nodes, so pipeline will be an array of path nodes, and I think this was linked to Tukmet's that's the adjacency list actually, right? That we have paths on one hand, then we link to, we have edge, we label, so that's what I did here, I labeled that way. Okay, so we basically, if I have element edge and element and path node, I'm having thoughts of decorated cospans here. What's up with my stream here? Still working. Video details. Stream. Yeah, still working. Video buffering. That's what's happening. Don't know. So here, basically, we could just say something like, we could take this. Well, actually, let's do it like that way. Let's take this, and then we could say that state pipeline is a graph of element edge and pad node, or just pads. Why is this so irregular here? To pad node to pad element edge is just the annotation, so the graph is between pad nodes, and yeah, it seems like apparently I decided to annotate things with element edges this here. Fine. But so first, of course, it's not polymorphic or heterogeneous in the way that we would like. But what else here? So pad node has an integer representing an identifier and a path type. And then a process has an identifier, and that's kind of how I did it. And then source and sink would just be, I suppose, yeah, trying to terminate, I think, my pipeline, saying if the pad is connected to an edge that's called source, then it means that it's kind of a live wire. It's which is the reason what I was thinking about decorated cosplans here. Let's get this decorated cosplans paper out, because I kind of want to have the I want to see the paper. That's the paper. It has the same thingies. So maybe I need to see the one for what hypergraph categories, the dynamic networks. I don't remember. Hypergraph categories, decorated cosplans. Yeah, something a bit more like this ish. But I think it wasn't that. It was maybe it was here. It might have been a Spivak thing. Still not the one I'm thinking of, but which paper is that? Algebra of open inter. Yeah, that sounds like that's the one. I think same paper, same graph. Categories, like we've seen some of those. Braidedness and wiggles, and we saw that in the paper. First one we opened, all of that, that seems to be exactly just that paper in the second part of that. But commuting diagrams and correlation, we've seen some of those. Some of it is basically this, but I'd like to see the version where it's like systems and composition of kind of wiring diagram of sorts, or not really composition of dynamic systems. Maybe that's where I should look for. It seems like that's all not what I'm thinking of. Maybe it's more the on the Evan Patterson side of things here. Signal flow, yes, we're getting to dynamic systems. So maybe it will be next. Linear networks, label graphs. Label graphs sound like at least something we've been thinking of now. I could be completely losing myself in wanting to see something that's not there here, which happens, but it's good. It's a tangent, so fine. Wires, no, not here. Okay. Decorated cosplans and open systems. Open, maybe, yeah, dynamic systems. It's not necessarily dynamic ones. Those. Oh boy, same ones again. Double categorical perspective. Yeah. I think I see Structured versus decorated cost bands. Brown is still not that. Okay, maybe I should look at images. It could just be something from like that's a bit more algebra of open dynamical systems. Yeah, maybe that. PDF on archive. Close to that, but the round version. I wanted the round version of it. But this is not bad, actually. Yeah. So compositionality here would mean that like a K is a source. It's an unconnected wire, whereas a connected wire. But I think in this model, you have to wire things, don't you? Well, maybe not, actually. Like this is unwired, and this is unwired. But oh yeah, violate the bijectivity condition, right? So yeah, no, this violates things. And so no, you can't have dangling wires, which is all good, I think. You compose systems until you don't have dangling wires, and you wire them up to the driver. The kind of streaming I/O, dialogue I/O abstraction thingy, which is really your OS in my view, I think. So there's another kind of shape there between agency symmetrics. Is that also like decorated cost band, all right, because it's the keyword, even though I'm kind of using it a little bit like a magical incantation, which really sums up to this notion of you define your ports and your wirings, so to speak, because that's very unlike this. So our guy's cool, but do we have the decorated cospan structure here? And I think, yeah, let's look at Patterson here. Did he do decorated cosbans, or am I imagining things? Yeah, no cosbans here. Yeah, because that's more about all logs and whatnot. But he did quite a bit on the whole dynamic systems series, I sort of saying, didn't he? Ah, in the structure cospan thing then. Oh, instead of decorated cospan, apparently. Well, let's take a look then. two ways to equip a category, an object of a category A with extra data: structuring, given a blah, and decorating, given a blah. First is more convenient for Open Patrinet, only second works for Open Dynamical Systems, so we want to relate the two approaches. An Open Patrinet with rates is a cost span of finite sets. We can also define patronets with rates. Da da da. Yeah, I think those are. Wait, a little bit. So those are all the inputs and outputs, and is that just sort of like the duality in how you can represent the dynamical systems? Without having this any of this fresh in my mind, it's really hard to parse. I think in the whole Julia, I think maybe in the yeah, I think it was in the Julia code for in the like cat Julia or cat lab, whatever they called it. Not in the blog then. I think it's one of the sub packages here, right? Cat lab. Right, there's this isomorphism between these wiring diagrams and these categories. So like how you wire categories. Right, yes, this is so that you can define them like point free or pointwise. And how is it done? Examples. Imperative interface. There we go. I think that's it, right? Categorical interface. Wiring diagram. This has evolved quite a lot. Yeah, so that's the definition of a category, and syntax systems. It's basically very similar in my mind. It's like the issue with like, or the what you do in arrow syntax in Haskell is like you manipulate things for which you give names to the ports, and the reuse of name between in those definition of ports signifies wiring. That's a particular way to think of wiring. Is it like in arrow syntax where ports get IDs, then ID reuse means wiring? That's an API. that's obviously, and that's why FRP people like arrow syntax, is because it's simpler than writing arrow code without points, which is more obfuscated, even though sometimes maybe it captures more of the meaning, which is this usual tension. Okay. All right. Well, I haven't made a tremendous amount of progress, but you know, the code that we had written still works. We're still moving forward on this design space of what kind of state do we attach our declarative representation to. And since the intuition is that it's a graph, we're kind of exploring the area of kind of graph representations around programming, trying to oscillate between something a bit more concrete and something a bit more abstract, and see whether that leads us to progressively sort of refine our view and pick a choice. So clearly there's like some theoretical difficulties there when we're going to try to make a heterogeneous graph, for instance. That's going to be quite the thing. Yeah, also here we see like probably it's like, is there like does this have a node bias? Is this node biased in the sense that then alga would be edge biased, meaning an edge is built from nodes. Here an edge is given to ports. This is a slightly different thing, right? So nodes are given to, nodes are given, node IDs are given to ports, to edges, right? So a connect, an edge, is made out of, well, actually in this case it's not nodes, but in the simple case it is nodes. In the complex case it's actually an existing graph. But so in fact in this case, right, it's the connection, although this is really cute from an algebraic inductive style standpoint, when we connect a subgraph in that way, then we create all of the possible edges, and that's might not be what we want, and that might create some constraints in how we create our graph that are not going to fit very well our data structures. So let me take a note for that. Given how alga connects subgraphs, or like fully connects subgraphs, basically, it might not be practical for our use case, because we're going to be struggling a little bit with this, which I think is why I went toward the describing an adjacency matrix, which, to be honest, even though it's a little bit ugly, it looks a bit more like, we init and we connect, we leave the source for the node. So here, except like, that's interesting. I see a symmetry here. Okay, so cool. Let's so alga would be something like edge the VID and VID, right? Well, really, it's actually a graph ID and it's a VID and a graph ID, sort of, right? Could be an edge, or could be a vertex, could be connect, yeah, could be connecting a whole subgraph, and that we don't want that. The graphs library is a bit like edge. It's like vertex and then all of the edges and vertexes. I mean, that's me, in fact, playing with like labeled edges as tuple annotations, right? Normally it's just V and outbound V's, but that's where we get. And then the arrow syntax is sort of V and kind of E and E. It's a bit like that. But you know what? We can say no, it's more like this. And then right? And then V prime can be bound to something that's actually the input of the whole arrow that's defined the kind of the an arrow block, or it could be an internal thing, and that seems like that's a pretty neat way to connect things, except that so the only thing I suppose is that it doesn't deal with hyperedges, but so does it? And is there another issue here? No, that's really the only one, because then you can actually have something like V is connected to like an E prime and that would be not connected or whatever, meaning there can be several inbound edges to a vertex, and that's totally fine. And also it's directed, right? So it's directed. So it's pretty neat. Which I suppose is maybe the reason why I went here a little bit into the free arrow kind of conversation, arrows, free arrows, and then maybe kind of essence of data flow programming. Maybe that's kind of where we need to go next time, is like arrows and then maybe free arrows. Okay, so let's note that down. Underlying state for GS shape, yeah. So apart from these theoretical questions, there's a kind of a to-do, to be honest. Choosing an underlying state data for pipeline, GS shape. I think we're, yeah, kind of, this is maybe all of that stuff is a bit like theoretical questions, isn't it? So I'm going to overwrite this with some to-dos here. Which will be try arrows plus free arrows plus there's this other thing. Come on out. What was it? The parametric higher order syntax for what? For structured graphs. Wait a second. Yes, it was for structured graphs. So yes, this. Yes. Right, so what was the benefit here? Wasn't it exactly something about the binding? Right, recursivity, like the ability to do recursive bindings in a graph, and then still be able to actually interpret this in the way you want, including like backlinks and so that's totally something we should explore. That's also very advanced but very interesting. Parametric higher order syntax and structured graphs. So I don't even know how that's really represented, what corresponds to that here, but let's add this. And 3 arrows and I mean, here we're going also more towards a compiler style representation. Maybe we can strip it off. It's sort of more programming language aspects, so that we only reuse the graph structure of it. Maybe that's possible. But it could be that actually we kind of get hooked and we need to do that, because that will give us maybe the kind of type polymorphism, like the heterogeneity that we want. Yeah, I'm quite excited to try that, but that will be for next time. So thank you so much for watching. I am Junchan, and we see each other on Saturday for some more exploration with that exact topic. Yeah, thank you very much, and I'll see you on Saturday. Bye bye.